Day 10, we've hit double digits. Always wonder, is this going to be the day when I won't be able to finish in one live stream? Problem like that happens every year. How are you? Avoid the ropes. Plunge in the river, swim to shore. Hell's yell something about meeting back upriver. River's too loud. Let's say it's the cathode ray tube, simple CPU, clock circuit. Precise clock circuit. Clock circuit ticks at a constant rate. Each tick is called a cycle. Start by figuring out the signal being sent by the CPU. CPU is a single register X. Starts at a value of 1 and only supports 2 instructions. Add X V. Takes 2 cycles to complete. After 2 cycles, the X register is increased by the value V. V can be negative. No op takes 1 cycle. CPU uses these instructions in a program. Consider the following small program. All right, this is our first test data. Fusion program, start. No op begins. X is 1 after the first cycle, no op does nothing. At X3, during the second cycle, X is still 1. During the third cycle, X is still 1. After the third cycle, add X sets X to 4. Start of the fourth cycle, add X, okay. Sure. You can learn something by looking at the value of the X register throughout the execution. For now, consider the signal strength, the cycle number multiplied by the value in the X register during the 20th cycle and every 40 cycles after that. That is during the 20th, 60th, 100th, 140th, 180th, and 220th. For example, consider this larger program. It's quite a bit larger, isn't it? During the 20th cycle. Okay, this is actually our first test data. Apparently, this is our first test data. Okay. The start of the first cycle. So we start at 1, right? And we start with X is 1, right? So we're going to say var X is 1. Throw new not implemented, right? Cycle is 1. Okay. So this wording is important. At the start of the second cycle, this begins. So during the second cycle, it's 1. During the third cycle, it's still 1. So it's not until the fourth cycle that it is 4. Okay. So we need to add up all of that, 20th and every 40 after. 20th and every 40 after. So we actually do have a result, which is fine. Return the result. Okay, so X is 1, cycles 1. For each var line in data. So basically, we want to say it's either add X with something or a no op, right? So if a line is no op, otherwise addend is, so addend, we'll start with 0. It's going to be long parse line starting at 6. All right, 0, 1, 2, 3, 4, 5, starting at 5, starting at 5, right? And then cycle count is 1. So we'll just do it like this. Cycle count is 2, and that. Okay. So we say cycle, we want the next interesting is 20, right? So cycle plus equals the cycle count. if cycle is greater than or equal to the next interesting, all right, we're going to say console write line at next interesting register is X and result is result. Okay, so then we're going to do that. We're going to say result plus equals X. And then we're going to say X plus equals end. That should give us what we need. The end is 2675. Let's put you over here and go see if we agree. We do not agree. Let's see where we disagree. During the 20th cycle, register X as a value of 21. At 20, oh, you know what? We really did this wrong. We forgot this. Next interesting is 40 more. Here. Whoops, here. Okay. Here we go. So we added them and didn't multiply them. Is that what the problem is? Well, let's see. 420. Oh, we have to multiply 21 by 20. We have to multiply 19 by 60. Okay, I see what I did here. Right? And so this is going to be register X and the result. So the result is X times the next interesting. Okay, yes, you can get rid of the parentheses, that's fine. 14,300. I think we're in the right ballpark now, right? But why not? So at 60, it's 19. You're at 100, it's 17, 18? Really? 20th cycle is 1 plus 15. Let's put the input. You can go over there. Let's put input over here. Let's put input here for the moment. All right, right about there. How about that? And then there's our result. You should be able to see all of that. Okay. Register is 21. 20 times 21. 20th cycle occurs in the middle of the second add X minus 1. 20th cycle is 1 plus 15 minus 11 plus 6 minus 3 plus 5 minus 1 minus 8 plus 13 plus 4 is 21. After the 60th cycle. I'm going to have to print this out every time, aren't I? Because we agree that it's 19, but at the 100th cycle, I say 17, you say 18. I say 30, you say 21. Then we get back to 16 and 18. So we've done something wrong here. That's not clear to me. Okay, let's do that then. Let's say let's make sure I'm reading this right. The start of the first cycle, the no-op instruction begins execution. During the first cycle, X is 1. After the first cycle, the no-op is done. After the first cycle, does that mean we're supposed to start at 0? Is that why we're supposed to start at 0? Okay. 21, 19, 18, 21, 16, 18, 13, 140. All right, I guess that's what we were supposed to do. That's fine. Let's get the real data, right? Let's get the real data. Let's put the real data in here. Let's run it. 13,480. 13,480. Why are you not taking my typing? 13,480. Let's go. That's the right answer. Okay. Part 2. Seems like the X register controls the horizontal position of the sprite. Specifically, the sprite is 3 pixels wide. The X register sets a horizontal position in the middle of the sprite. Okay. There's no vertical. The sprite's horizontal position puts in pixels where CRT is currently drawing. Those pixels will be drawn. Counts pixels in CRT, 40 wide and 6 high. The CRT screen draws on the top row of pixels left to right, then the row below that, and so on. The leftmost pixel of each row is 0. Okay. Leftmost pixel is 0, and the rightmost pixel is 39. That makes sense. Like the CPU, CRT is tied closely. Draws a single pixel during each cycle. Representing each pixel of the screen as a number, here are the cycles during which the first and last pixels in each row are drawn. So by carefully timing CPU the CRT drawings, you should be able to determine whether the sprite is visible the instant each pixel is drawn. If the sprite is positioned such that one of its 3 pixels is the pixel currently being drawn, the screen produces a lit pixel, otherwise the screen leaves the pixel dark. First 3 pixels from the larger example are as follows. So let's get the old data back in here. All right. Start cycle 1, begin adding 15. So we draw 0, which means we have during cycle 1, CRT draws 0. Okay, that's correct because our position is 1. So 0, 1, 2. So there's the sprite's position. Let's begin adding. All right, so at the end of cycle 2, finish adding 15. So you draw a dot, you come back. That's the sprite, you draw that, you move, you draw that, okay. I get that. Allowing the program to run to completion causes the CRT to produce the following image. Render the image given by your program. What 8 capital letters appear on your CRT? Okay, so we need to print this out, right? Let's go ahead and bring this over here because we want to look at that anyway, right? So during part 2, all right, we're going to do all of this again, kind of, except not really. Sure, you can return 0. We don't have a result. Okay, so X is 1, cycle 0. We don't care about next interesting because that's something that we don't care about. Result, plus, okay, right, so we don't care about result, we don't care about next interesting, we just care about X. So given this, we want to say while cycle count is greater than 0, all right, the first thing we want to do is, given where we are, we're going to say cycle plus, we don't actually have to say cycle plus plus, we can wait and do that. We'll do that actually later, right? And then cycle count double minus, right? And then we're going to say is if cycle, let's do math absolute of X minus cycle. Yeah, it doesn't matter. I'm doing absolutes, it doesn't matter. Is less than 2, then we're going to console write this. Otherwise, we're going to console write this, right? Then we're going to use cycle and cycle count, and we're going to say if cycle mod 40 is 0, then we're going to do a console write line, right? And then that happens there, which is fine. And then we'll do an extra console write line for good measure. Let's get rid of this console write line. And let's see what happens with our test data. Isn't that funny? Our test data looked not wrong on the first line. What did we do wrong here? So right, so that's that line. I don't understand. I have lost my understanding here. Something. Is this must be right? Let's console write X. Let's see what's going on here. Okay, so we need to go back to 1, right? And so target is, let's see, target is cycle mod 40. All right, and so X minus target. Okay, do we get the picture now? Okay, looks like we get the picture now, I think. Yep, that looks like the picture. Okay, let's go back to the final data. Let's get some letters. We have EG. We have, all right, come back here. EGJB, EGJB, GCFK, GCFK. Okay, good. Not too bad. We've seen problems like this before in Advent of Code, where you end up having to print out something and look at the letters. So that's not an entirely new thing for us. No real major issues with this today. Thinking about how this might get refactored, I actually don't know how much commonality there is here. I think, we sort of have this notion of running through the cycles and maybe doing something at every cycle. That might be a way to factor this out so that the majority of this is common code. And then just, in this case, we sort of do this every time, right? As well as that. And then in this case, we basically have to do this part. So that might be a way to sort of simplify it out. I might try and do that before I push this up. So I think that's it for today, and we'll see you tomorrow for day 11. Oh, please share your GitHub link. Yes, before I go. So the GitHub link is here at the bottom, right? It's here at the bottom. So it's github.com/bradwilson/advent-2022. Unfortunately, that's not super big to read, but maybe this would be better. github.com, Brad Wilson, Advent 2022, and then, can I make this bigger? I can make that a little bit bigger, right? That's the link right there. That's where you'll find the code. Cool. All right. Yeah, so look for the code, 15 minutes maybe. Give me a chance to sort of look this over and decide how the best way to refactor this might look. And yeah, with that, I'll see you tomorrow.